So, one of the things we want to look at in this class are some applications of quadratics, so there are a couple different kinds or types, or I guess characteristic questions that you should be prepared for in this particular class. And so one of them, is question one, example one here, where it says, suppose you have some function, in this case it's just a linear function. What's the minimum value of the product 6xy? And so, in other words, if you picked some x and obviously then some y that would go along here, and then took it times 6, what's the smallest possible output you can get? And green is fine, but I'm more interested in that thickness. There you go. Okay, so maybe you said, x is equal to -3, and 4/3 of -3 is -4. -4 plus 2 is -2. So I know the point -3, -2 is on this function. If I do 6 times -3 times -2, that product, 6 times -3 times -2 is equal to 36. So is that the smallest product, right? Is that the least I can get? Maybe I can get a smaller product. Like, what if I picked, 0, right? And if I picked 0, so then I say 0, and then the y value is 2. So then I could say, well, the product is 6 times 0 times 2, which is 0. 0 is much smaller than 36. So is 0 the smallest product? And so, and maybe it's not even an integer. Maybe I have to pick out, a rational value, or it could be irrational value. I don't know. So, that's kind of what the idea here is that what is the smallest possible value of this product given any xy pair that fits that graph times 6? And then is there a way that we can systematically or very efficiently find this without guessing and checking? Okay, so the first thing I want to do is actually express this product as a function. So your product is 6xy, but I want it to be a function in terms of just x. So I want to get rid of this y value, right? I want to sub out what y equals to, and it says right here, well, that's what y equals, right? Y equals 4/3 x plus 2. So what I'm going to do is then go back and rewrite this. So my product is equal to 6x times 4/3 x plus 2. And I can distribute this 6x into this particular parenthesis. So my product is equal to 24 divided by 3, so 8. 8x squared. 6x times 2 is plus 12x. Okay, so now this is a quadratic function now. And it's a quadratic function that actually is opening in the up direction, right? Because our coefficient is positive 8. So if I were to be able to graph this quadratic function, I know that the vertex of this, which since our graph is opening up, the vertex is going to represent a minimum value. And that's exactly what I'm looking for, is a minimum value. So I want to find the vertex here, because if I can find the vertex, that x value is going to tell me when do I have a minimum, and the y value is going to tell me what is that value and what is that minimum value equal to. So I want to practice completing the square, because it is one of my favorite things to do. So I want to complete this square, so I'm going to factor out that 8. Right, take out this 8 here, and that means it's x squared plus, and then 12 over 8 x. I know I can reduce that. 12 over 8 reduces to divided each by 4, so 3 over 2. X squared plus 3 over 2x, right? And then remember the technique of completing the square. It works as a fraction too. You take half that number and square it. So half of 3 halves is 3/4. And then squaring 3/4. So again, a half of 3 halves, so 3 halves, half of that is 3/4, and then we want to square 3/4. Oops, So when you square 3/4, remember it's equal to the top squared and the bottom squared. So 9/16. So I'm going to add 9/16 to that particular parentheses to complete that square. Now, immediately after, I need to subtract 9/16 to balance. But if you are really savvy at completing the square, you know that this is really not a 9/16. It's a 9/16 that's under the influence of this 8. All right. So if you distribute this 8, that's really 72/16, or thinking about this 8 dividing into 16, that's really a 2 on the bottom. So this is like a 9/2 in disguise. So that's what I have to actually subtract as a 9/2. So minus 9/2. And again, thinking about distributing this 8, right, that's 72/16. And again, if you divided both of those by 8, that's equal to 9/2. So that's where I'm getting this value, right? So I'm getting 9/2 here. So I'm going to immediately subtract 9/2. Okay, so then now we can, oops, there it is. Now we can rewrite this in factored form. So we have our product is equal to 8 times x plus 3/4 squared, because remember 3/4 plus 3/4 was that 3/2. 3/4 times 3/4 is 9/16 minus 9/2. So this is our vertex form. Now, the two things, so here's our vertex. It's negative 3/4, comma, negative 9/2. Okay. And so that's really messy. I apologize. So let me fix that. Let's clean it up. So negative 3/4, comma, negative 9/2. So this right here is the x value, right? This right here, that x, that tells you when it happens. This will have a minimum when x is negative 3/4. Now, if you want to know what is that value, what is that minimum, then that's this y value. The y answers the what. Okay, so the x is the when, the y is the what. And I'm going to ask you that on your homework and on quizzes. I might say, what is the minimum value? So if I'm asking for what is the minimum value, then all I want is the y value. If that's what I'm asking for, if I'm asking for the what, then I just want the y. If I ask, well, when did it happen? Then I want the x. So the minimum value is negative 9/2. When does it happen? When x is negative 3/4. And you could also just put this x value of negative 3/4 into here if you wanted to know what's the corresponding pair, right? So when x is, oops, jumbo highlight. Okay, I don't want highlight, I want pen. There we go. So when x is negative 3/4, the y value, so if I do 4/3 times negative 3/4, that's negative, what is that, negative 1 plus 2, so 1. So the ordered pair on the graph is negative 3/4, 1. If I multiply those two values together, I get negative 3/4, and then I take it times 6. So my product would be 6 times negative 3/4 times 1, which is negative 18/4, which is negative 9/2. See, so, and I already knew that because that's what my function, since I created a function that was based on that y value, that's exactly what happened. So, okay. So, hopefully this example made sense. And then if you have any questions, certainly ask. And then once this made sense, then check out the next video for the next example.